Hello YouTubers, we have another little pulse motor we built here we want to show you. I have this one running off a wall wart right now, not the little battery pack is showing there. It's going at slightly higher than 6,000 RPM running from the wall wart. With the batteries it'll run around 5,000 RPM. In the back here you can see it's levitating. Got a little bit of wobble going on. Let's see if I can get that under control here. When I move this thing around, gets a little vibration in it. But what I normally do is just run it off the battery pack there at actually 9 volts. Those are hooked up in parallel. Let me turn it off a second. Okay, we got the single coil circuit here. A couple sets of magnets glued on to a needle. Our standard propeller. Okay. These little curved plastic things I found came in real handy to center this back magnet with just a needle so it wouldn't have that wobble inside. And this tiny magnet here in the back is to stabilize it so it doesn't wobble too much. And I actually at the moment have to add another magnet back here to reinforce it, because this just has like a 1/64 of an inch variance in what you can do on adjustment wise, getting it too close where this wants to jump here or too far when it gets vibration. So it's a fine adjustment there. And here is Lidmotor's circuit for that, for the black pulse motor we just saw. Also, another circuit from Lidmotor, this Hall effect sensor. I built one that has 2 coils in series here instead of just the 1 coil. And all you have to do on those 2 coils in series is make sure that the facing part of the coil does opposite things. Doesn't matter if you got this pushing against north and this pushing against south. As long as they're doing opposite things, that's the only wiring you need to worry about in that. This is the Hall effect sensor. Let me get the camera studied here. This is the Hall effect sensor motor here. Turn it on. It runs at least 6,000 RPM. It's running off that little battery there, 9-volt battery. You can rotate this thing around. It's the needle's being held by a magnet at the top. It has a little holder at the bottom, a little hole where the bottom of the needle is retained from going all over the place. And I picked up a little switch out of something or another and put it in the circuit. Comes in handy. And of course the spherical neodymium satellite magnet going here is going off a Lidmotor's basic electronic pulse motor circuit. Very simple, 1 transistor and a diode. These 2 sets of windings, it's just basically you're going to have 4 wires coming out, 2 from one coil and 2 from another coil. Those basically use that much wire on each coil from one of these coils out of a microwave oven fan. So I don't know exactly what gauge it is, but 1 complete of these for one coil, 1 complete of these for the other coil, and that completes the coils. Lidmotor's circuit for that looks like this right here. And again, you don't have to have the coils on opposite sides. You can move this coil over and have both coils on one side. That's what I'm doing. built me a new mount for this VCR component Hall effect motor. Let me get it going here. You can hear it goes tremendously fast. I'll try to move the camera in, we can pick up the sound better. A little different angle here on it, and it uses the same Hall effect sensor circuit from Lidmotor, only it just uses one big coil instead of the two coils that this one over here uses. Just one more added thing. I hooked this one up, disconnected this battery and hooked it up to a 12 volt 100 milliamp wall wart. And it is going at 7,000 RPM. Add a little bit more magnetic stabilization up top to see if that would help speed it up. But also what's interesting about this one, the diagram, the circuit diagram does show a diode to protect the Hall effect sensor. But in this one I forgot to put the diode in, and it's not killing the sensor. So that's pretty interesting, that you can run this thing at 12 volts with a Hall effect sensor, no diode, and it doesn't burn out. So there you go.